Hello friends, welcome back to the lecture series on engineering mathematics. In today's session, we are going to discuss about the Fourier series. In this module, we are going to discuss about a little bit history associated with Fourier series. Then we recall some basic concepts like periodic function, its properties, as well as even and odd functions along with their properties, and then we define the Dirichlet conditions essential for Fourier series. So let's start with the introduction. The key to understand the Fourier series is our ancient desire to express everything in terms of circles, or the most exceptionally simple and elegant abstract human construct. Fourier believed that trigonometric series could represent any arbitrary function, so that he came up with an ingenious method to find the necessary coefficients, that is radius of as well as frequency of the circles for any generic function. Here the term generic will represent the integrable function. So he thought that any continuous and integrable function can be converted in terms of a periodic function so that it goes on repeating itself. In 1807, Fourier introduced the series for the purpose of solving heat equations in a metal plate, and his work have been processed and formally presented by Dirichlet as well as Euler, and the Fourier series representation along with Fourier coefficients is given by the Euler. So before going to Fourier series, we are going to discuss about the prerequisite or the basic concepts like the periodic functions. Any function f of x is said to be periodic if for all real variables x for the given function f of x there exists some positive integer t such that f of x plus t is equal to f of x. So this represents your function is periodic, where that positive term t is known as fundamental or primitive period of that function. For example, trigonometric functions cos x as well as sin x are the periodic functions whose period is 2 pi. So for getting an idea about the periodic function, if we consider the graph of cos x. So first we start with whenever x is equal to 0, cos 0 is equal to 1, and at pi by 2 it is 0. At pi it is minus 1. At 3 pi by 2 it is equal to 0, and at pi this value is equal to 1. So after this your function will start repeating its value. So from 0 to 2 pi it achieved the same function value. So it means after this period, after the period t is equal to 2 pi, your function will start repeating its values. So we are getting a wave like structure. Same is the case with sin x. Instead of 1 when x is equal to 0, so we start with 0, pi by 2, pi, 3 pi by 2 and 2 pi. So this is your value plus 1 at pi, at 3 pi by 2 sine 3 pi by 2 is minus 1, and at 2 pi. So after this we are getting the same function value. So it means sin x is periodic function with period 2 pi. Now there are some important remarks related to the periodic functions. If f of x is periodic function with period t, then f of ax is the periodic function with period t upon a. So for this we consider standard trigonometric function sin x. We know that sin x is periodic with function with period 2 pi. So if we draw the graph, so when this value is equal to pi, this value is 2 pi. So when x is equal to 0, sin 0 is 0. At pi by 2 it is 1, At pi it is 0, 3 pi by 2 minus 1, 0. So the same structure will repeat again. So as we consider sine 2x, so here your value is pi, this value is 2 pi. So when x is equal to 0, sine is 0 at pi by 2. So when x is equal to pi by 2, so this value will be 0. At 3 pi by 2 it is minus 1. At pi it is 0. So the initial and final value is repeated here, and after this it will start repeating. So this is the initial part where we are getting unique values for the function. So it means period of sine 2x is equal to pi, or we can apply the same criteria as this is equal to 2 pi upon 2, where value of a is equal to 2. Same is the case with sine 3x. If this is your pi, this is your value 2 pi. So we are getting the output like this. So this is your value 2 pi by 3. Now we discuss even and odd functions. Let f of x be a single valued continuous function defined in some range. Then f of x is said to be even function if f of x is defined in the interval minus L to L. Then after replacing x by minus x, your function remains unchanged. Then we call the given function as even function. If range of the function is 0 to 2L, then it is said to be even function if f of 2L minus x is f of x itself, or geometrically, if the curve of f of x is symmetric about y-axis or the vertical axis, then we call the given function as even function. For example, cos x, even powers of variable x, or any constant functions are always even function. Similarly, we can go for odd function. F of x is said to be odd function in the interval minus L to L if we get f of minus x is equal to negative times f of x. Means after replacing x by minus x, your function changes its sign. Then we call that function in the given range as odd function. If range of the interval is 0 to 2L, then if f of x changes its sign when x is replaced by 2L minus x, then we call it as odd function. If you replace L by pi, then any trigonometric function will be periodic function in that given range 0 to 2 pi, and then we can check even and odd properties by using this definition. And geometrically, given function is said to be odd function if it is symmetric about x-axis, that is horizontal axis. For example, sin x or any odd power of x will give us the odd function. Now let's discuss some properties of even and odd function. First one, arithmetic properties. So if we consider f of x and g of x are two functions, then we discuss about the addition or subtraction of two functions as well as multiplication and division of two functions. If we consider f is even, g is even, then addition as well as multiplication of two even function is always even. Addition or multiplication of two odd function is always odd and even respectively. But when we deal with one odd and one even function, their addition is neither even nor odd. So we can justify this by using the definitions. Similarly, there are some integral properties of even and odd functions. If your range is minus L to L for the given function f of x, as we consider this is your minus L, somewhere here is L, and in the center there is 0. So this is your f of x. If your function is even function, so if you replace x by minus x, we get the same function f of x. So integration from minus L to 0 is same as integration from 0 to L. So that's why we take integration 2 times 0 to L for even functions only. But if your function is odd, this will be negative times f of x. So whatever integration you calculate in this range minus L to 0, that will be negative times integration in this range. So if you add them together, then they will cancel each other, so we get 0. So this is very important property, integration of even and odd function. Remember, we are going to take integration, or we are going to apply this integral properties for the range minus L to L only. So this will help us to evaluate the Fourier coefficients in next module.